see some of the figures. Then 86, when I started cryo, even I am not sure what is cryo. So I started reading books and low physics. Maybe your physics professor can tell you what is low temperature physics. So we have seen. So first I started with the gases, hydrogen and gas, and it was a very small, test. Yeah, next one. Yeah, this is the one I was telling. Our Indian government, they want to develop only low Earth orbit for PSLV and GSLV. So we are now successfully having two workhorse engines. And these are all the small rockets. When I was young and DSSC, we were developing we call it the sounding rockets. These are all in the age of 68 to 72. Then next, then we have gone to slightly the one. This is 300 series and 560. Next. Yeah, this is a strap-on solid bigger motor. First time you have developed. What you are having inside is T-bond. Polybutadiene nitrile alkali is the polypropellant. And now currently we are using HTPB. Hydroxy terminated polybutadiene is the propellant, and which is now powering the PSLV strap-on. Next one. So you could see how the inside the rocket, the propellant is there with the propellant. This is the one which is burning and giving you this one. This is a 200-ton engine. Recently we have made the biggest one. So these are all the cross section of the one. Next. So next, I think I started the liquid. What you are seeing on the right side, biggest one is the Viking engine, what we got from France. We developed in India. The first engine I integrated at Bangalore when Dr. U.R. Rao was chief. Then later, after the first test, I was asked to do the credit. Can you go to the next one? Maybe you could see a small, this is a turbo pump for the same engine. Next. And this is the closed circuit, what we got from France. Next. And this is the engine test. Okay, next. This is the cryo. So I started in a small way. Then later I had many problems in cryogenetic development. So while starting, when I started to a small scale, then later I created a 1-ton engine printed or used in my CSIR Karaikudi. We made electro deposition route. I prepared, I put a small mini hydrogen plant at the Mahendragiri. So I used liquid hydrogen and liquid oxygen. Big explodes. Not 1, 2, 3. Everybody started making fun of me. All these fellows can. So I was a little bit worried. My wife asked why you are so much worried. I said everything is going like that. And on the day I was thinking, this hydrogen is like a Maharaja. When it flows on the pipeline, it freezes everything. Whether it is nitrogen or any gas, it will be freezed because its boiling temperature is going to be Kelvin. So nitrogen or any gas will be freeze. So when I opened up, all dirt will become solid and goes and bust. So if that is the case, if it is like a Maharaja, definitely there will be a Maharani to control. So even today morning, my wife said, "You go there and properly take." Yes, madam, I will do that. So definitely for hydrogen also there will be a Maharani to control. Who is the Maharani? The Maharani is helium. So next day I got some tip. So I purchased the helium. I started a line left and right with helium. You believe it or not, extended this was so nice, very good. So everybody was appreciating, and our UR gave me a good this one, and he gave me a 16 crore project to develop a cryo project. I started, maybe good or bad, I don't know. The Russians came. He said, "Why you are struggling? I am having the technology, I am ready to teach." Well, I have also not seen Moscow. So I said, yes, I will also come. So like that, a 500 crore was signed, and I was the project lead to go there to acquire the technology from Russia. So maybe along with acquiring the technology, I've heard the good company of Sratan there. He was studying at that time in Moscow University. So I had a very good, yeah, you are also there. So we were very happy. So I started learning full cryo, both good things and bad things. And finally, of course, geopolitically, Americans didn't like. They said, you don't give the technology to the Indians. So due to the pressure, finally we were asked to come out. So within 8 to 9 months, we came and I started the cryo program and I have given the project report to the government. Luckily, I think they kind enough to give me a 300 crore project. I was the first project director to develop the cryo. So this is a engine. I used to go to most of the universities. I believe the professors and the students can do a lot of work. So this is the first CAD model I built in Anna University. They have a CAD center. So similarly, many universities I go, IIT Kharagpur, they have a cryo this thing. Can you go to the next graph? So I put out of 300 crore, 100 crore for testing the engine at Mahendragiri. Now I have put one more small hydrogen plant. Now currently there are 2 liquid hydrogen plants in India. One is in ISRO, one is in Talku in Andhra Pradesh. They are using helium cycle to cool it. Next. So next one, this is the test of course. Now currently, next. They are now planning. GSLV is very successful. Now manned mission is on the card, and I am also a member. So I used to go there and we are discussing. Maybe I am not very sure. Maybe it may take 2 or 2 years time. It's a very costly affair. So whether it is required, still people are debating whether we have to send or not. It is only a okay. My neighbor has sent, so I will also send. So that may be the reason, if at all, if you want to send. Can you go to the next one? So now one more is Aditya L1 mission. Maybe you may be interested because this will be in the launching ground point where the gravity of the Earth and Sun will be revealed. So if you put that point, you can watch the Sun very carefully. So the Americans and also trying to help us. So we are trying to put this one. So these are all the few next. Yeah. Now current trend is you may be seeing US and SpaceX has come in a very big way. They want to go in a cheaper way. They don't want to, even a common man has to fly and commercialize and kind of thing. They started working. Parallelly, there are many private companies. They started even in China as well as New Zealand and in India. So next one, maybe the New Zealand man has already put the small satellite. A similar one, India also now we are planning. Because if you take a PSLV, it may be about 400 crore. If students want to build a small satellite, they want to launch, that is not possible. If it is around 20 crore, maybe your vice chancellor may agree to give money to put a satellite maybe next time. So we are now building in ISRO in next one. So in India, we started a company called Skyroot, and very 2 youngsters, they from ISRO, they took voluntary retirement and they started this company. One is Pawan and Bharat. They asked me, can you come as and sit with us guiding? I said, fine. But later they said, you be with us. So I am now the vice president of the company. Nearly about 150 people now we are working. And I am looking after all the cryo stage as well as the liquid engine. I have already fired, maybe you can go next. You could see now I am not like olden techniques. I will follow only the old routes and other things. Now the latest thing is 3D printing. Any metal can be, any shape you want, you can print. Those days, cryo engine, I took almost 6 months to print. Now in 6 weeks, I will get one engine. That is a kind of technology advancement. So we have that, you can see the 3D printed machine. So I have printed a machine and I have fired with, not with liquid oxygen and liquid hydrogen, even though I love to have hydrogen, but hydrogen has a lot of issues like density stress and kind of thing. So now, because it's a private company, we are looking for a cheaper launch cost. So I am trying to use LNG, liquefied natural gas, which is almost cost of your petrol or slightly costly, maybe 100 rupees. So can you go to the next one? So you could see this is the engine I have printed at Pune. and we have mounted and in the Nagpur place, and you see this is the first private bio engine I have built and I have fired new thing, learned for it. How I am trying to do it at 1000 Newton, and maybe that will power. Like, so, so now little bit about for your because we are going only up to moon or something, but you are interested to go interstellar, so long distances kind of thing. So how to go? What fuel will use? The only solution is the nuclear. But why so far we could not do? The problem is if the first stage or second stage failed, the nuclear, the power plant will come down and we have only 1 year. We don't want to spoil. Already we spoiled the maximum, but we don't want to spoil further also. So the country wise they were taken not to use the nuclear power, but still people are working. Already Nova is ready and the Russians, both of them are ready. So in future, for the satellite to travel months and months, we may require electric propulsion as well as the nuclear propulsion. So that is the one I want to put. You might have heard about the physics people about RTG, radioisotope thermal generator. So if any metal decay, you will this is the RTG. So you may, I think, Peltier effect might have appeared, and you are having a two differential temperature with the two metal this thing, you will get electricity. So you can get with this is the one now currently people are using it for interplanetary missions and kind of things. People are working. We are also working on that. Next one. So in addition to that, we are working on next one. Yeah, plasma, and we have now a very small plasma thrusters in ISRO. And when I was there in Russia, I could get some collaborative program with them, and they have given some technology. So we already started developing 15 millinewton thruster. Now currently around 75 millinewton thruster is also on. So maybe in future, this will also rule for going to interplanetary. We will work for that. The fuel is the xenon. I think your chemistry major studies the xenon is the lowest potential you can break, and then you can do that. That's why we are very good one. Can you go to the next? So this is the future vehicle. If you want to go to another sun or star or the what, wherever you want. And now people are working variable impulse plasma thrusters. It is already on, and maybe with the RF generators, and we are trying to. In India, we have not started. Some people are working only in the universities and other things. But Americans, they have paid a lot of money. They have funded for this program. Next. So two things, small things I want to tell you. Maybe when Hasan wants to take me to the observatory, and we have seen the moon on the night. Maybe those days I used to say, my wife, your face looks like a moon, beautiful moon. But now I am not telling, because through the telescope, if you see there are undulations and kind of thing. So if you are very closely, if you see that, it will be a different issue. But the observatory here, when you are putting, there is a lot of light pollution and clouds and so many things obstruct to see the stars and other things clearly. So now the aim is, they already put long back the telescope in the space itself, so that these kind of problems are all not there. So mainly the probe and satellites. So there are you might have already seen Galileo telescope as well as Huygens thing. Both are more than 20 years. It was there, and it was given a lot of data. As very clearly your workshop, I also used to tell in the rocketry, when we do the rocket test, there will be hundreds of parameters like pressure, temperature, vibration, so much we will record. But once the success, everybody will clap and everybody will go. Who will see the data of it? But very small thing represents some issue, something. The physical change which is giving is done by that. Maybe your data, what we have received from many satellites and telescope and other things, enormous, but no one is there to properly analyze and tell us. Maybe this workshop, what he has organized. I have gone through glimpse of that. I find it will be very, very, very useful. And I'm very happy. Some of you may read later. You can find out some of the new things from that also. That will be good. Can you go to the next graph? So these are all the props and Voyager as well as the thing one. So they have gone interstellar space and they have given beautiful photographs. What we were not knowing about Saturn and about rings and the new moons and everything. Yes, even once it has photographed one of the comet has come and collided with this one. That also it has published. Yeah, so nicely it is giving. So the data can be properly analyzed. That's what I'm trying. Can you go to the next view? So see how beautifully the photograph has been taken by those telescope and Voyager and other things. Next. Maybe last one I would like to tell, even though I said in the ground we are having light pollution, this pollution, that pollution. Now space is also getting polluted. You could see 1 million objects is going around the Earth. And much earlier, most of the third stage and it will be going around, there will be some propellant. After some time, it will explode. It will become small particles. So now everything is going around the Earth. Like dirty streets. Now the space also is becoming like that. So now there is a program how to clean it, how to sweep it. So that itself is now Japanese are working as well as 2 satellites now currently they are planning to send. Can you go to the next view? So there are like this, all old satellites and other things are all roaming around. Next one, yeah, more than 1 million 1 centimeter size is already taken. And now internationally, everybody has joined and they are cataloging all these unwanted things and they are putting it. So, next one. Maybe a few more, I will stop. Yeah, these are all the techniques to clean. They can put the water wall or even Russians, they said you put another satellite and you go and kick it towards the Earth so that it will come back. And magnetic and fishnet, so many techniques. Even a last moment after 7 years, you can have a balloon that will be. Now they are planning to bring back most of the debris to the Earth. Next, of course, this is my always I used to tell this one. If you break a egg, the life ends. If the egg breaks off its own, a life begins. So the ideas and creative things, it has to come from your mind. I wish all of you to have a nice, good workshop. Thank you very much for listening.
Thank you, sir, for a very interesting and informative talk. I hope the students will learn a lot from your fascinating journey throughout. Thank you, sir. Now, I humbly request our Honorable Vice Chancellor, Professor Syed Ainul Hassan, and Chief Guest of today's program to deliver his presidential address and give his valuable remarks. Sir, please.
Our key speaker, Mr. Gandhi, dignitaries on the dais, friends, ladies and gentlemen. It was indeed we have witnessed for the last 30 minutes. And it was indeed a wonderful experience for me personally. But yes, first of all, you give a big hand to Mr. Gandhi. You know, I have very little to do with these researches. It's not my cup of tea at all. But yes, now there is a talk about not only interdisciplinary, rather multidisciplinary. Well, I can take that advantage. I'm not here to deliver a talk. As I said, this is not my field, but I'm invited here not as an individual, as a scholar, rather on behalf of the Vice Chancellor. So, when you say spaceship, there definitely we wish to have similar kind of researches on our campus. You know, why I say that I have little to do with this subject also. I'm very, moved with these developments. And he started from scratch, how the entire journey for a period of time involving Indians, Germans, Russians, Americans, French. This has been going on. And I remember, and I recall those days when I was teaching at West State University of New Jersey. Princeton was not very far, it was just, 5 miles away. And then I happened to come across a scientist who worked in the laboratory of Einstein. And he was calling himself as a student of Einstein. He was Professor Martin. And then when he found a person belonging to the discipline of language, literature, and culture, and particularly Iranian and Central Asian studies, and of course having a little knowledge about the Arab world. Then he offered that, look, let us sit together and do a project together. Then we started working on 3, we selected 3. One was Ibn Rushd, then Farabi, and Edison. Because, these people were not having access to polymath only. Rather, they were people of physics. It is starting from very beginning, from 7th century onwards. There was aura of Greek philosophers, and then they turned the table towards logics, and then finally physics. And then they would take us, taking you to the metaphysics also. But yes, the wonder of the centuries, appearance of Ghazali, appearance of Al-Biruni, and then Zakaria Razi. He lost his vision due to the chemical reaction. No, in the 8th century, 9th century. And then finally in 16th century, saw Mullah Sadra. They have put a lot of effort in order to occupy this space and see the physical conditions, etc. And combining them together. And finally, on one hand, it was, of course, it's the Europeans and Americans, Russians, but rather we forget that our scholars also made remarkable research. And then today, you adopt theory of gravity and relativity, whatever you call it, Einstein and the theory, Big Bang theory, whatever you can. But yes, we should go back to history also. Because when you perceive things only in a very, very set compass, in a very set canvas, then somehow you see lack. And the vision also, we we feel ourselves helpless. So what I see that present is incomplete without past, and future cannot be imagined without present and past. So therefore, there are certain interconnected bodies. Now we have seen that just now, how he has started. I mean, talking about this South Indian researchers, and then taking it to ISRO, and then now developing it further. So these are, ways to understand things in that perspective. And we should carry forward. And this is the best opportunity. We should make use of these researches to combine them with other researchers and see what is the result. I, started searching, as I said, we completed a project, and that project it was published in fact from Princeton University. And then it was project was Cosmic Challenges and Obligation of Man. This was paper in fact appreciated. But what I say, you make effort, come out of the galaxies and see what else is there. This time. Now we hope that we will, in the presence of Professor Shaki, Professor Najmul Hassan Saab, our Salman Saab, Basha Saab, and of course, Madam here. First time I am. Yes, I have a lot of hope. The prayers and you carry forward the entire hope. But I can see many other faces sitting here, the all scientists, and you. Who is the best? Let us see. Coming 2 years or 3 years, we will have something, some kind. Dr. Gandhi. Thank you. Thank you very much.
Thank you, sir, for your valuable thoughts and giving a different perspective on this topic. Thank you. Now we have come to the end of this inaugural session, but I have a formal vote of thanks. I would like to thank all the participants who are physically present here and those who joined online to make this program a success. I especially thank our Honorable Vice Chancellor, Professor Syed Ainul Hassan, for sparing his valuable time and sharing his thoughts. Thank you, sir. It is my privilege to thank Padma Shri Vasudevan Gandhi, sir, for giving such a wonderful and inspiring talk. He presented the topic in a very simple way, covering historical perspective to the latest research in the area of rocketry. Professor Shakil Ahmed, Professor H. Alim Basha, for their constant support all through the organizing of this workshop. मैं हमारे स्कूल ऑफ साइंसेस के तमाम साथियों का भी शुक्रिया अदा करूंगा जिन्होंने हमें हर वक्त साथ दिया इस प्रोग्राम के दौरान। मैं नॉन टीचिंग स्टाफ का भी शुक्रिया अदा करूंगा जिनके बिना ये मुमकिन नहीं था ये प्रोग्राम ऑर्गेनाइज करना। मैं खास तौर से आईएमसी मानू का भी शुक्रगुजार हूँ जिन्होंने कवरेज किया इस प्रोग्राम का, और तमाम उन लोगों का भी मशहूर हूँ जिन्होंने किसी भी तरह से हमें मदद दी है। मैं हर एक का नाम लेना मुमकिन नहीं है मेरे लिए, पर मैं आप तमाम का भी शुक्रिया अदा करता हूँ। मैं एक बार फिर सभी पार्टिसिपेंट्स का शुक्रिया अदा करता हूँ and I hope they benefit from this workshop. This vote of thanks will not be complete if I don't thank the convener and co-convener of this workshop, Professor Najmul Hassan and Dr. Priya Hassan, for putting together such a wonderful workshop, and I wish them success for this workshop. Thank you all once again. And now I request all of you to stand up for the national anthem.